Imagine a world where software writes itself. Sounds like science fiction, right? Well, meet Devin, the world's first AI software engineer. Devin is not a human sitting at a computer. It's a powerful artificial intelligence, a complex algorithm trained on massive amounts of code. Devin can understand your instructions, write code, and even fix bugs. It's a game changer in the world of software development. Devin is still under development, but it's already showing incredible potential. It can build basic websites, create simple apps, and even generate code in multiple programming languages. While it may not be ready to replace human developers entirely, Devin represents a significant leap forward in AI capabilities. Its arrival heralds a new era in software development, one where AI plays an increasingly prominent role. The emergence of Devin raises many questions about the future of software development and the role of human developers. Will AI replace human jobs? Will it lead to a future where coding is automated? These are important questions to consider as we enter this exciting new frontier. Devin's abilities seem almost magical, but its inner workings are rooted in advanced technology. This technology is a blend of sophisticated algorithms, powerful computing resources, and vast amounts of data. It's a marvel of modern engineering designed to mimic the way humans learn and process information. At its core, Devin is a deep learning model. Deep learning is a subset of machine learning, which itself is a branch of artificial intelligence. This model is built using layers of artificial neurons that process information in a way that is inspired by the human brain. This means it learns from vast data sets, much like the human brain learns from experience. Just as our brains form connections and strengthen them through repeated exposure to information, Devin's neural network adjusts its parameters to improve its performance over time. But instead of experiencing the world through senses, Devin devours code. It processes and analyzes code in a way that allows it to understand the underlying principles and patterns. Millions of lines of code, written by human programmers, have been fed into Devin's system. This extensive dataset includes examples from various programming languages, styles, and applications, providing a rich source of information for Devin to learn from. This massive dataset allows Devin to identify patterns, learn programming languages, and understand the logic behind software development. It can recognize common structures, syntax, and even the intent behind the code. Think of it like this. Imagine giving a child thousands of Lego sets and instructions. Each set represents a different problem or project, and the instructions are the code that needs to be followed to complete it. The child starts by following the instructions, learning how different bricks fit together. They begin to understand the basic principles of construction and how to follow a plan. Over time, the child develops an intuitive understanding of building, eventually creating their own structures without instructions. Devin works similarly. It starts by learning from existing code, but eventually it can create new code based on its understanding. It has analyzed countless lines of code, learning the rules and patterns of software development. This deep analysis allows Devin to understand not just the syntax, but the logic and reasoning behind the code. This enables Devin to write its own code, following your instructions and adapting to new challenges. It can take a high-level description of a problem and generate a solution in the form of code. The process is complex, involving intricate algorithms and massive computing power. These algorithms are designed to optimize Devin's learning process, ensuring that it can handle a wide range of programming tasks. But the result is an AI that can understand and generate human-readable code. This means that the code Devin produces is not just functional, but also readable and maintainable by human programmers. This is a significant achievement in artificial intelligence, pushing the boundaries of what we thought possible. Devin represents a new era in AI where machines can not only assist with coding, but also innovate and create in ways that were previously unimaginable. The arrival of an AI software engineer like Devin has sparked both excitement and concern among human developers. Some fear that AI like Devin could eventually replace human jobs in the tech industry. It's a valid concern. As AI technology advances, it's natural to wonder if machines will eventually outperform humans in tasks that were once considered uniquely human. However, instead of viewing AI as a threat, many developers see it as a powerful tool, a partner in the coding process. Imagine Devin handling repetitive tasks like writing boilerplate code or debugging simple errors. This would free up human developers to focus on more creative and complex aspects of software development, like designing innovative features or solving challenging problems. In this scenario, AI augments human capabilities, leading to increased productivity and innovation. The future of software development likely lies in collaboration between humans and AI. By embracing the strengths of both, we can create a future where AI assists human ingenuity, leading to even more sophisticated and powerful software solutions. Section 4: AI in Action: Real-World Examples. The impact of AI on software development is not just a futuristic concept, it's already happening. Today, AI is being woven into the fabric of software development, making processes more efficient and innovative. Numerous companies are integrating AI into their development processes, and honestly, the results are impressive. From small startups to large tech giants, AI is becoming a cornerstone of modern software development. For instance, GitHub, a platform used by millions of developers worldwide, has introduced GitHub Copilot, an AI-powered coding assistant. This tool is revolutionizing the way developers write code. Copilot can suggest lines of code, complete functions, and even generate entire blocks of code based on your comments. Imagine the time saved and the reduction in repetitive tasks. It's like having a virtual pair programmer who can anticipate your needs and accelerate your coding. This not only boosts productivity, but also enhances the quality of the code being written. Another example is Google's AutoML, a suite of machine learning products that enables developers with limited machine learning expertise to build high-quality models. This democratizes AI, making it accessible to a broader audience. AutoML automates the process of selecting algorithms, tuning parameters, and optimizing models, making AI development accessible to a wider range of developers. This means that even those without deep technical expertise can create powerful AI models. These are just a few examples of how AI is transforming the software development landscape. The integration of AI into development processes is leading to more innovative solutions and streamlined workflows. As AI technology continues to evolve, we can expect even more sophisticated tools and applications to emerge, further blurring the line between human and machine in the coding world. The future holds immense potential for AI-driven development. These examples demonstrate that AI is not just a futuristic dream, it's already changing how we build software. The impact of AI is being felt across the industry, from speeding up development cycles to enhancing the capabilities of developers. As AI tools become more powerful and user-friendly, they will continue to reshape the software development landscape, opening up new possibilities for innovation and efficiency. The future of software development is bright, with AI leading the charge towards more intelligent and efficient coding practices. The journey of AI in software development is just beginning. As we continue to explore and harness the power of AI, we will unlock new levels of creativity and problem solving. The collaboration between human ingenuity and AI capabilities promises a future where software development is more dynamic and impactful than ever before. In conclusion, AI is not just an add-on to the software development process, it is becoming an integral part of it. By embracing AI, developers can push the boundaries of what is possible, creating software that is not only functional, but also innovative and efficient. The real-world examples we've discussed are just the tip of the iceberg, and the potential for AI in software development is limitless. Section 5: The Ethics of AI, a Balancing Act. While the potential of AI in software development is undeniable, its transformative power brings both opportunities and challenges. It's crucial to address the ethical considerations that come with this powerful technology. These considerations are not just technical issues, but touch upon fundamental human values and societal norms. One of the primary concerns is the potential for bias in AI-generated code. Bias can manifest in various ways, from gender and racial biases to more subtle forms of discrimination. Since AI models are trained on existing data, they are only as good as the data they learn from. They can inherit and even amplify biases present in that data. For instance, if the training data is skewed or unrepresentative, the AI's outputs will reflect those same biases. If an AI model is trained primarily on code written by a particular demographic, it may not generalize well to other contexts. It might generate code that reflects the biases of that group, potentially leading to unfair or discriminatory outcomes. This can have serious implications, especially in critical applications like healthcare or criminal justice, potentially leading to unfair or discriminatory outcomes. Addressing these biases requires a concerted effort to diversify training data and implement fairness-aware algorithms. Another ethical concern is the issue of accountability. In a world increasingly reliant on AI, determining responsibility is more complex than ever. If an AI system generates faulty code that leads to negative consequences, who is responsible? The ripple effects of such errors can be far-reaching. Is it the developer who used the AI tool, who might have trusted the AI's output without sufficient oversight? The company that created the AI, which might have failed to ensure the robustness and fairness of their product? Or is it the AI itself, an entity without consciousness or intent? These are complex questions without easy answers. They require a multi-stakeholder approach, involving developers, companies, regulators, and society at large. As AI becomes more integrated into software development, the need for ethical guidelines becomes more pressing. These guidelines should be designed to prevent harm and promote fairness. It's essential to establish clear guidelines and regulations to ensure responsible AI usage. Regulatory bodies and industry standards can play a pivotal role in this. Addressing these ethical concerns is crucial for building trust in AI systems and ensuring that AI is used for good. Open discussions, ethical frameworks, and transparency in AI development are key, and ongoing monitoring are essential for navigating the ethical complexities of AI in software development. Continuous evaluation and adaptation of ethical standards will help in mitigating risks and maximizing the benefits of AI.